So welcome everybody to this latest GCSE Vision video on 162 Maths, and in this video we'll be going over a topic test on higher factors and multiple questions. Now there will be a copy of the question sheet in the description below for you to download and have a go before watching the video as we go through the answers. So let's get started on this GCSE higher topic test on factors and multiples. Now there's no indication about whether these questions are calculator or non-calculator, so where we will be bothered and not be bothered using a calculator will be based on how we're feeling. So for question 1, we've got x equals 3 squared times 5 and y equals 2 times 5 squared, and the question is asking us to circle the lowest common multiple of x and y. Now in terms of this, we can work out what x and y are. So x equals 9 times 5, which is 45, and with y we've got 2 times 5 squared, so 2 times 25, which is 50. So looking at this, which of these is going to be the lowest common multiple? It's going to be 450. Now for 280, we need to write this as a product of its prime. Now if you've got a calculator, I can do this easily by typing in 280 equals and then pressing shift and fact, and it gives me the answer straight away. So it's 2 to the power of 3 times 5 times 7. Now what you could have done is used a bit of working out. So you could have done a factor tree, and again starting numbers could be entirely up to you. 35 and 2, 5 and 7, and there we've got our answer. Now we're looking at question 2b. It says 588 is equal to 2 squared times 3 times 7 squared, and the question is asking us to work out the highest common factor of 280 and 588. Now there's a couple of ways in which you can do this. You can use a Venn diagram, but I always tend to prefer just using the product of their prime. So I've got 280 equals 2 times 2 times 2 times 5 times 7, and 588 equals 2 times 2 times 3 times 7 times 7. Now if I just circle the common ones we've got and then pick one line and times the numbers together, so I've got 2 times 2 times 7 gives me a final answer of 28. Then looking at question 3b, it says a, b and c are different prime numbers. Work out a set of values for a, b and c so that a plus b equals 2c. Now there's a few combinations you could have. So one possible combination you could have is 3, not 2. Let's change that. So we've got 3, 7 and 5. That would work. Or another combination you could have is 5, 17 and 11. There are loads of different combinations you could have, but I would say those two are probably the most common that most students would pick. For question 4, it says that a number is an odd multiple of 3 and has a common factor of 180 and 750. So if we look at it, and says the question is asking us to work out the greatest possible value of the number. So for this, let's look at the odd multiples of 3, and that's going to be 3, 9, 15, 21, 27, 33. So again, increasing with the power number of difference of 6. And then if we're looking at the common factors of 180 and 750, well, the common factors we could have are going to be equal to 1, but that's going to be the same. We've got 2, 3, 5, 6, 10, 15 and 30. So in terms of this, which numbers appears both? Well, it's going to be 15, so the answer is 15. Then moving on to question 5, it says circle the square root of x when x is 2 squared times 5 squared times 11 to the power of 4. Now when we're multiplying, we can just square root each individual thing. So square root of 2 squared is 2, square root of 5 squared is 5, and the square root of 11 to the power of 4 is 11 squared. So that then becomes 2 times 5 times 11 squared. 2 times 5 is 10. 11 squared is 121. So 10 times 121 is 1210. Now looking at question 6, it says that a and b are two numbers between 0 and 100. A is a prime number and b is 3 times of a. Work out the smallest and largest possible values of a plus b. Now in terms of this, as b is 3 times the size of a, and if I then do 100 divided by 3, I'm going to get 33.3 recurring. So from this we can then assume that a is going to be less than 33. So then if I then find out all the prime numbers that are less than 33, I end up with not 1, we end up with 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. Now, if B is 3 times the size of A, then if A is its smallest value, which is 2, then B is going to be 6. And if A is the biggest number, then B is going to be 93. Because obviously then if B was the next prime number, which is going to be 37, then B would therefore be a 3-digit number, which would be 111. And that wouldn't work. So in terms of this, to find the smallest possible number, it's going to be 2 plus 6, which is 8. And to find the largest number, it's going to be 31 plus 93, which is 124. Then moving on to question 7, it says which of these is not a square number. So all we need to do here is actually just work out the answers and then square root. So 2 squared times 4 to the power of 3, press equals, square root the answer, and you get 16, so that's fine. Then I then do the next one, so 2 squared times 8 to the power of 3, which equals that, square root the answer, and that gives me a not square number, so it's going to be this one here. So looking at question 8, it says that a menu has 8 starters, 6 main courses and 6 desserts. Beth wants a starter and a main course. Chen wants a main course and a dessert. How many more possible combinations can Beth have than Chen? So in terms of Beth's combinations, all you need to do is just simply multiply how many there are. So here we've got 8 times 6, which is 48. And with Chen's combos, we've got 6 times 6, which is 36. And if we take away those two numbers, we have a difference of 12. Then moving on to question 9, it says the padlock has a 4-digit code. Each digit can be 1, 2, 3, 4, 5 or 6. For example, here's a number. It says the 4th digit must be an even number. How many possible codes are there? Well, in terms of the first number, so let's just write the first number. Well, how many numbers are there to choose from? Well, in terms of this, we can have any of those 6 numbers. So there's 6 possible numbers. In the second number, again, there's no mention of this. So again, we can have a possible of 6. Our third number, again, could be any of those 6. However, our fourth number has to be an even number. So that's 1, 2, or 3. So there's only 3 of those. So then to work out the total number of combinations, we've got to do 6 times 6 times 6 times 3, which if I get my calculator and just get that out there, and we've got 6 times 6 times 6 times 3, we get an answer of 648. And there is our final answer and our last question on this topic test on factors and multiples.